So our lesson for today is definition of derivative. What do we mean by derivative? So let's consider this function. So it is any curve. I will pick a point on this function. It's called a here. And my aim is to find the slope at that point. We know that the slope of a straight line, we can find the slope of straight line. We pick any 2 points on the line and we find the slope. But here you have a curve, not a straight line. So what I'm gonna do is to draw a tangent line passing through that point. So this is the tangent line. It passes through point A, and remember that what I want to find is the slope of that tangent line. Remember that the slope of a line is y2 minus y1 over x2 minus x1. But here the problem is that you have only one point through this tangent line. So, and I want to find the slope at that point. So what I'm gonna do is to pick another point on the curve. Let's call it B. And I will draw a line passing through AB. This is a secant line, okay, in red. This line passes through these 2 points A and B. So what I'm gonna do is to find the slope of the line AB passing through A and B, and I'm gonna estimate um, the slope of the tangent line passing through A by approaching B to A. So if you approach B to A, you will get a better estimation of the slope passing through A, so of the slope of the tangent line. So as you can see, as I approach B to A, I'll get a better estimation of the slope of the tangent line. So actually that's what we're gonna do. We're gonna find the limit as B approaches the point A, which is the point of tangent C, to get a better estimation of the slope. How we're gonna do that? Let's locate the coordinates of my point A. So my point A, let's say it has this is the x value, x coordinates, and it has y coordinates. I will call them x and f of x. So x here and f of x for the y value of A. Similarly for point B, so this is the x value of point B, and this is the y value of point B. So I will call this, or I will highlight this x value here, and here I will highlight it in pink. I will call this part h. So the x coordinates of the point B is x plus h, okay, and then the y coordinates of my point B is f of x plus h. So the length from here to here is x plus h. This is the x coordinates of my point B. So f of x plus h is the y coordinates of my point B. I will locate it here. So now I have 2 points of coordinates known as x, f of x plus h, and f of x plus h. So I can use the slope formula that we already know. So the slope is equal to, I will write it here, so I'm finding the slope of the secant line AB Okay, we know that it is y2 minus y1 over x2 minus x1. Since point A has coordinates x, f of x, this is x and y. B has coordinates x plus h, f of x plus h. F of x plus h means the corresponding y value of x plus h. Now you subtract y2 minus y1 over x2 minus x1. So I will get f of x plus h minus f of x. So I'm subtracting the y values here, okay, over x2 minus x1. So it means x plus h minus x. So x plus h minus x. So this is the slope of the secant line AB. Now as you can see here, I can simplify by x, right? X minus x, they cancel out. So I'll be left with f of x plus h minus f of x over h. So this is approximately equal to the slope of the tangent line. What we said that we're gonna move the point B towards A so that I can have a better approximation. So actually I will move point A towards point B, okay, sorry, I will move point B towards point A, so as you can see the trace here, so that I will get a better approximation of the slope of the line tangent at point A. So to do that, it's like you're moving, so H will move towards the value X, is like H tends to 0. Okay, so when I moved point B towards A, so H also will be moved towards X, so H tends to be like equal to X, which means that H tends to 0. So what you have to do is to get an exact approximation of the slope at the point of tangency A, of the tangent line here, tangent at A, you have to take the limit as h tends to 0 of the slope that you have found. So here what we're gonna do is to find the limit as h tends to 0 of f of x plus h minus f of x over h, and this gives me exactly the slope of the tangent line at a point on any curve. So actually the derivative is nothing but the slope of um, um, the tangent line, or you can say it's the slope at a point on any curve. So it is the instantaneous slope at a point on any curve. We will denote the derivative of a function by f prime of x. So this notation, this prime here, means the derivative of my function f. So we'll denote it as f prime of x, which is equal to the limit as h tends to 0 of f of x plus h minus f of x over h. So this is the definition of the derivative of a function at any point x. So that's it for knowing what do we mean by derivative of a function. So what you have to know is this formula, this definition, and the next video will learn about how do we find the derivative of any function using the definition of derivative. Thank you.